Hi, now we're going to be taking a look at all 6 trig functions. We're going to learn how to evaluate using all 6, not just the first 3. The first 3 that you guys are used to is sine, cosine, and tangent. And cosecant is the reciprocal of sine. As you can see, the opposite and the hypotenuse switch spots. Secant is the reciprocal of cosine, which is now hypotenuse over adjacent. And cotangent is now adjacent over opposite, as it's the reciprocal of tangent. Another way of writing that is cosecant is equal to 1 over the sine of theta. So by flipping the fraction, it's the same thing as saying 1 over that trig function. Hence why secant is 1 over cosine and cotangent is 1 over tangent of theta. So we're going to take a look and see how do I actually evaluate these. And we have our first example here. Sine, cosine, and tangent, that's pretty straightforward. We have opposite over hypotenuse. So that would be from this angle right here. Here's our reference angle. 5 would be our adjacent side. 12 is our opposite side. And we don't know the hypotenuse. We got to find it. But thankfully, we know that 5, 12, and 13 make a Pythagorean triple. So I'm going to write triple up here. So that means it would be 12 over 13. Cosine is adjacent over hypotenuse, so that would give us 5 over 13. And then finally, tangent is opposite over adjacent, and that would give us 12 over 5. Okay? Now, as we recall, we have the cosecant, which is the reciprocal of sine. So it would be hypotenuse over opposite. So 13 over 12. For secant, we would have hypotenuse over adjacent because it's the reciprocal of cosine, and that would be 13 over 5. And then finally, cotangent is the reciprocal of tangent. So instead of opposite over adjacent, it's now adjacent over opposite. So that'd get us 5 over 12. So the new 3 are really just reciprocals of the original sine, cosine, and tangent. To evaluate the 6 trig functions, given sine of theta is 4 over 7. So if we recall sine, it's opposite over hypotenuse. So if we draw a picture, opposite would be 4, hypotenuse would be 7. We have to find the adjacent side. In order to do that, we do have to actually use Pythagorean theorem because this is not a Pythagorean triple. That means the 7 would be our C value because it's the hypotenuse. So 4 squared plus x squared is equal to 7 squared. 16 plus x squared is equal to 49. We're going to subtract 16, and we get 33. And then finally, we take the square root of 33. So x is equal to the square root of 33. So this entire side length has a radical in it, which is fine. We can still work with that when we write up our ratios. The only thing that you want to recall is that radicals cannot be in the denominator. So I'm going to kind of box this a little bit, or at least start it for when we get to that point. So sine, again, is opposite over hypotenuse. So we have given to us in the directions is 4 over 7. Cosine is adjacent over hypotenuse, so we have square root of 33 over 7, which is fine because the radical is only in the numerator. Tangent is opposite over adjacent, which is 4 over square root of 33. And this is the problem, is that we can't have that radical in denominator, so we have to rationalize it. So I'm going to multiply both the numerator and denominator by that square root of 33. So we get 4 square root of 33 all over 33. Because square root of 33 times square root of 33 is going to be a perfect square under the square root, which essentially the radicals cancel each other out, so you're left with just 33. So this is the answer for tangent of theta. All right, let's take a look at the next column. We have cosecant. It is hypotenuse over opposite, so it's really just the reciprocal of 4/7, which is 7/4. And then secant is the reciprocal of cosine, so it would be hypotenuse over adjacent, which is 7/√33. Well, dang it, there's that one again where we have to actually multiply by the reciprocal, so we have to multiply by √33 over √33. So cosecant would be 7 times √33 over 33. Okay. And then finally, cotangent would be the reciprocal of tangent of our red answer, not our final answer. So it would be adjacent over opposite. So √33 over 4. Okay. So we're doing the same thing that we started the trig unit in, is just being able to write the ratios. And if we are not given one of the side lengths of the triangle, we have to find it using Pythagorean theorem. And now we have an added layer. If one of the sides is a radical, you have to make sure that there's no radical in your final answer in the denominator. And then finally, last example, let's put this all together. We are going to be solving for all the angles and all the sides of the triangle. So the angles are probably the easiest because if you already know 2 of them, you can always find the third one. So let's start with that. We already know that C is 90 degrees. We know that angle A is 28 degrees. And if I add those together, subtract from 180, or actually this plus this is equal to 90, then I know that this measure is 62 degrees. We are also told that B is 15. So just from the given, you know 4 out of the 6 steps. Pretty straightforward. Now we have to use trig to help us solve the rest. So for our first one, let's go ahead and solve for A. We have this is our reference angle, 15 is our adjacent side, A is our opposite side. So that would be tangent of 28 is equal to A over 15. We multiply 15 by the tangent of 28, and we get 7.98 rounded for our answer for A. Then let's go ahead and solve for C. In C, we get that equaling the hypotenuse. So I'm going to use my given length, which is my adjacent, to my hypotenuse. So this time we have cosine of 28 is equal to 15 divided by C. We can cross multiply. So we have C times, that's confusing, C times the cosine of 28 is equal to 15. Divide by cosine of 28 on both sides. And we get 17.0 rounded. So it's pretty close to 17 as our 2 sides. And so that's what we're going to be doing with these new trig ratios, is once you're given a couple pieces of info, like one angle, one side length, being able to figure out all the other parts to that triangle. Thanks.